Hello children, welcome to Zero Panic Maths. Okay, in today's session, let us continue our discussion on the fractions and rational numbers, a concept of the world of numbers. In the previous session, we have seen the exercise set 3.1 and 3.2, wherein we discussed the different kinds of number systems in the world of numbers, starting with the natural numbers and included with zero, which is called as a whole number. And after that, there is an integer which includes the set of positive numbers and its counterparts, the negative numbers, with zero inside that. Okay, so in the number line, in the previous session we have seen, in the number line we have seen the numbers like 1 2 3, like this, started with 0 1 2 3, and to the left side of it, you know that it is -1, -2, and -3. So now the concept, the filling the spaces, why it is called as filling the spaces, because there is some space. You can imagine that there is some space between 0 to 1, 1 to 2, 2 to 3. What are those numbers which are in between those numbers? Filling that space are the numbers which are called as fractions, and they are of the kind of rational numbers. Okay, so you can see an example. Say for example, if you are preparing some dish and there is a recipe which calls for half a cup of ghee. Okay, there is a simple example. Or say suppose there is a recipe going on and they are saying that half teaspoon of sugar should be added to that. How do you measure that half? Okay, so that is what is, how do you represent that mathematically? A half a spoon of ghee, how do you measure that? That is a fraction. Okay, so we actually called the fractions as the numbers that represents parts of a whole are called as fractions. Parts of a whole. Say for example, if you are saying 4 as one whole number, okay, so making say two parts of that whole is actually called as 2 by 4, something like that. Okay, so it is a fraction. Or you can say half, 1 by 2. So you are dividing that one whole number into two equal parts. You are dividing two numbers into four equal parts. That is what is meant by the fractions. Or some fractions include rational and irrational numbers. We will discuss that later. But currently you should be knowing that the number that fills between the two whole numbers is called as a fraction. Okay, or a fraction can be in the range of negative numbers and it can be in the range of positive numbers also. So there will be, say they are saying here, just as every natural number has an additive inverse. Okay, say for the integers, what is an additive inverse? Additive inverse is such a number adding which to itself gives you 0. Okay, that is called as additive inverse. See, 3 has -3. -3 is the additive inverse of 3. Additive inverse means adding -3 to the 3, it will give you 0. Similarly, 19 has -19. Add -19 to 19, you will get 0, right? So that is called as additive inverse. So simply additive inverse is nothing but the negative counterpart of the actual number. Okay, 3 minus 3, 19 minus 9, 10 minus 10, something like that. Okay, so we can conceive of additive inverses of every positive fraction also. Okay, so it is 3 by 4. 3 by 4 is 4 parts of 3 whole number. So minus 3 by 4 is for 3 by 4. So if there is something called as 3 by 4, that might arise between 1 and 2. Okay, it is a less than one number, right? So if it is a number, if there is a number between 0 and 1, that is 3 by 4, there will be a number minus 3 by 4 between 0 and -1. That is what it says. Okay, additive inverse for fractions as well. Similarly, minus 19 by 7 is an additive inverse of plus 19 by 7. Okay, so don't worry about the additive inverses and all. So all in all, what you have to understand is if there is a numbers, positive integers and negative integers on the number line, there are some numbers that exist between the two given numbers or one unit, that is called as a fraction, and fractions will have negative counterparts also. That is what the concept that you need to understand. Okay, don't worry about all these explanations and all. Okay, and now you need to actually concentrate on the definition of what is a rational number is. So simply, rational number, when we combine all the integers and all the fractions, both positive and negative, we get a set of rational numbers, and that is denoted by q. Okay, now as I've already told you in the last class, okay, listen to me carefully, we have discussed a set of natural numbers, okay, which started with 1, 2, 3, which are the actual numbers used for counting. Added with 0, there is a whole number. Okay, there is no description of whole numbers in your syllabus, but it is a number set, which is a superset of natural numbers with 0 included into it, whole numbers. And then we went to integers, and integers are defined represented by z. Okay, and integers will have 0, plus 1 and minus 1, plus 2 and minus 2, and so on. These are integers. Okay, now we have seen one more set of numbers, which are called as fractions, and fractions lie between the two integers, positive integers or negative integers. Such, okay, now if you have numbers like 3 by 4, minus 1 by 2, something like that, okay, any numbers, all these set of natural numbers, positive integers, negative integers, 0 and fractions, all that together is called as a rational number. You understood that? You understood, right? So rational number is a set of numbers we have studied till now, all that. Okay, so that is what they are saying. When we combine all integers and all fractions, when we say integers, we are actually dealing with whole numbers also, because integer has a 0, and we are dealing with the natural numbers also, because natural numbers are actually the positive integers only. Okay, so positive integers, negative integers, 0 and all fractions together is called as a rational number. Okay, and that set is represented by q. Okay, rational numbers is represented by a symbol q, and q actually meant for quotient. Q actually meant for quotient. Okay, which is something which we will discuss in the division of some number. Okay, so rational number. Okay, now if in general, if you define a rational number, we are saying, okay, so this is an example of rational number 2 by 4. Okay, so with this reference only, there is a definition of rational number we can derive, that is, a rational number is defined as any number that can be expressed in the form of p by q. Okay, you are defining it in the form of p by q. See, p is the numerator and q is the denominator, provided p and q are integers, where p and q are integers and q should not be equal to 0. So there are conditions. Any number that can be represented in the form of p by q, as we have discussed here, okay, or represented here, and where p and q are integers. Integers means they should be belonging to this set only. Okay, they should be either plus some numbers or minus some numbers. Okay, it can be 0 in p, but it cannot be 0 in the denominator. Q cannot be 0. Why Q cannot be 0? Because that will become an infinite number. That's why. Okay, anything by 0 is an infinity. That's why. Okay, so you understood the definition. How do you define a rational number? Rational number is defined as any number that can be expressed in the form of p by q, where p and q are both integers, but an additional condition, q, though 0 is also an integer, but q should not be equal to 0. That is the definition that is finally given. Okay, so when a definition for rational number is asked, you should be writing the last line, that is the definition of a rational number. But what does the rational number set contains is, it contains or it combines all the integers, positive integers, negative integers, and then all positive fractions and negative fractions with 0. That is a set of rational numbers, and this is the definition. You understood, right? Okay. Now let us quickly move to observe some of the important points. Okay. Now, as we have defined, the rational numbers also include the natural numbers. We said already, rational numbers include natural numbers because natural numbers are in turn the positive integers only. The whole numbers are the numbers with zero, okay, and integers. We are saying integers also because integers will actually provide us to have the negative values inside that, okay. And what is the extra condition that we defined is p by q. In the form of p by q we represent, where p and q are integers. It means p and q can have any negative number, positive number, like this. Any positive and negative numbers it can have, with some condition that q should not be equal to 0. You can have 0 in the numerator, as I already told. Okay. Okay. So rational numbers do not have unique representation in the form of p by q. Okay, there are some important points we are discussing. Okay, so this is the definition. Now this is about, listen to me carefully. They are saying rational numbers do not have a unique representation in the form p by q. So when you are representing some rational number p by q, in the form of p by q, then that is not the unique representation of rational number. What do you mean by that? What do you mean by not a unique representation? That where p and q are integers and q not equal to 0, with that condition, if you are representing, say for example, if you are defining 1 by 3, okay, forget about minus, okay, that is another example only, but forget about minus and see 1 by 3. 1 by 3 is also equal to 2 by 6, and these two rational numbers are actually equal. Okay, so there is no unique representation, right? When you are representing 1 by 3 as 1 in the numerator and 3 in the denominator, it is also similar to representing 2 by 6, because 2 ones are and 2 threes are, and it is also equal to 3 by 9 also, because 3 ones are and 3 threes are. Okay, so that way it is also 1 by 3, it is also 1 by 3, it is also 1 by 3. Even if you have 10 by 30, that is also 1 by 3 only. So that is the reason we say that it is not a unique representation in the form of p by q. Okay, because all these are equivalent rational numbers. All these are equivalent rational numbers only, or also called as equivalent fractions. Equivalent fractions, because fractions are are part of a whole number. We are saying, see, uh, 1 divided into 3 parts is exactly similar to 2 divided into 6 parts, because those are two actually equal parts only. Now the thing is, the common understanding is that when we say that p by q is a rational number, when we represent the p by q on the number line. Okay, so as I already told you that on the number line, if you go for representing the fractions, because number line usually contains the whole numbers or positive and negative integers only. Okay, and a number that assigns between the value of which is assigned between the two given numbers is a fraction. So when you go for representing that fraction onto the number line, what happens is, the number line, we assume that q is not equal to 0, of course. Okay, and then p and q have no common factors other than 1. Okay, and that is p and q are co-primes. Now this point you need to read and understand it carefully, because you see, they are saying p and q, when a fraction is represented in the form of p by q, then p and q should not have a common factor other than 1. It means they should be both co-primes. So what do you mean by that? See, suppose we will take this example only. See, when I say a fraction 1 by 3, which is equal to 2 by 6 only, here 2 by 6 is also equivalent to 1 by 3, because 2 and 6 are not co-primes, because there is one common number between 2 and 6, and that is 2. And what is that 2? See, 3 into 2. I can write 2 by 6 in the form of 1 into 2 and 3 into 2. Similarly, between 10 by 30 also, there is one common factor which is 10. Okay, so you can write 10 as 1 into 10 and 30 as 3 into 10. It means that 10 by 30 has, or 10 and 30 have one common factor 10 which is other than 1. It means that when you are representing, it is only when you are representing the fraction onto the number line, you should be careful that P and Q should not have any common factors other than 1, because then they will be equivalent numbers only. So what I am trying to say here is, when you are representing 1 by 3 on the number line, somewhere here 1 by 3 is something like between 0.33 it will come, between 0 and 1 somewhere here it will come. Okay, 1 by 3. But if you go for representing 2 by 6, it will not come between 2 and 3, it will also come between 0 and 1 only, and that is exactly equal to 1 by 3. It is the same thing. When you try to represent 10 by 30 or 3 by 9, that also is this number only, 1 by 3 only. You're getting my point? Okay, so that is the reason they are saying, when you represent P by Q on the number line, when you are representing, then we should assume that Q should not be equal to 0. That is a default point only. But also P and Q have no common factors other than 1. So when you are asked to represent 10 by 30 or even 26 divided by 6078, that is also equal to 1 by 3 only. Okay, so when you are asked to represent this onto the number line, that is actually 1 by 3 only. So you should reduce that to a form where it should not have any common, both numerator and denominator should not have any common factor other than 1. Not having any factors other than 1 are also called as co-prime numbers. Those two numbers should be co-prime numbers. Understood this? Okay, and that is the last point also. When we represent that fraction onto the number line, this is the rule that we need to follow. Okay, hope you understood this. Okay, now let us quickly move to the some of the important laws, okay, that can be used for performing certain arithmetic operations onto the fractions and rational numbers. Okay, so equality, when two rational numbers are said to be equal. Okay, listen to me carefully, these are very simple laws only, but you need to make a note of this, and based on these laws only, the next coming exercise set should be resolved. Okay. Okay. Now, two rational numbers A by B and C by D are said to be equal when AD is equal to BC. It's very simple. When A by B and C by D, the cross multiplication should happen. A into D, see, A into D should be equal to B into C. Okay, obviously. Okay, so that is the first rule. Okay, there is nothing to explain more. I will not explain it. Okay, addition and subtraction law. Okay, so for two rational numbers, when you add and subtract, what should be the important point to remember, and how the addition subtraction should be performed? Okay, now assume that we have two numbers, A by B and C by D only, but before you start adding the two numbers, you should convert the denominator of the two numbers to equal value. That is the reason they are saying it should be converted into A by B and C by B. You see that both the denominators of the both the fractions are same only. Okay, you should, if they are not same, then you should convert them to same by performing certain arithmetic operations. Then it can be added easily. So then they will be converted into the form A by B plus C by B. Then B, since it is common, you can keep it as a common denominator and add both the numerators A plus C. Similarly, for subtracting also, you should be converting the denominator of both the fractions to the equal denominator B, and when it is converted, then you can keep a common denominator and subtract the numerators of both the numbers directly, and that will give you addition and subtraction. You understood, right? Okay, now coming to multiplication and division law. Multiplication and division law for rational numbers. Okay, now first thing, we will see multiplication. You see that multiplication when a by b multiplied by c by d. Okay, now when I'm saying a by b and c by d, it is a generic form of a rational number. Okay, nothing more than that. So when there is a fraction a by b is multiplied with c by d, the numerators are multiplied and denominators are multiplied. See, a into c into b into d. That is what the result that you are going to get. It's a simple thing only. But when it comes to division, there is a slight difference. That suppose a by b, listen to me carefully, a by b divided by c by d. When such a division is given, you can convert this division into multiplication by taking the reciprocal of the second number. Listen to me carefully what I'm saying. Keep a by b as it is. Convert this division into multiplication. When you convert division into multiplication, the second number will become reverse. So that here it is becoming c, d by c. D by c. It was c by d previously. So when it is converted into this format, now the rule of multiplication applies, and numerator are multiplied, AD, and denominators are multiplied. It will get you BC. But to perform this, you should have this condition that B should not be equal to 0. Initially, B should not be equal to 0 and C should not be equal to 0. And when you actually reverse that, even D should not also be equal to 0. That is what is a rule of division. Understood, right? Okay, multiplication, multiply both numerator to both denominators. When it is given division, convert that to multiplication and apply the rule of multiplication. Okay, hope you are getting it. Okay, now with the arithmetic laws defined as above, okay, these are all the arithmetic laws, simple laws only. With that, we have addition and multiplication, both are commutative. Okay, we say addition and multiplications are commutative. Okay, you might be knowing what is commutative, but let me give you a simple example of a plus b is equal to b plus a. Addition and multiplication, they are saying addition and multiplication. It means that a multiplied by b is equal to b multiplied by a. It means that when you perform addition and multiplication operations, the values, or you can say the operands, when they are reversed, then also the result will not change. It means that you see that 2 plus 3 is equal to 3 plus 2. If you change the values, if you take 3 before 2, then does the value change? 2 plus 3 is also 5 and 3 plus 2 is also 5. That is what is called as addition is commutative. Addition is commutative. Similarly, multiplication also, 2 into 3 is exactly equal to 3 into 2. Multiplying by reversing the values or operand values does not make any difference in the result. That is what is it is said here, that with the arithmetic laws defined above, addition and multiplications both are commutative. Understood this? Okay, so that they are saying, see, the fractions, it applies to fractions also. A by b plus c by d, you are adding two fractions, a by b and c by d. But if you keep c by d first and then add a by b to it, the result will not be different and it will be same. That is what they are trying to say here. Understood, right? Okay, similarly, it applies to multiplication also, that a by b multiplied by c by d is exactly equal to taking the first c by d and then multiplying a by b. Okay, they also follow the distributive law also, distributivity law. Maybe you might have studied it in the 8th class. What is the distributive law? Okay, suppose PQ are three fractions, then P multiplied by Q plus R. Okay, you are keeping Q and R are the two fractions only. P, Q, R, all three fractions or rational numbers. Then P multiplied into bracket Q plus R is equal to P into Q plus P into R. PQ plus PR. You see that? PQ and plus P into R. So this is what is called as distributivity law. You are distributing it. Okay, here it is non-distributive and here it is distributed. P is distributed to both Q and R. Okay, this law which is applied to basic numbers in the number system is applied to rational numbers also. That is what they want to say. Understood, right? Okay, so in addition to the basic arithmetic operations like addition, subtraction, multiplication, division, they are saying the fractions will be applied with commutative law. Okay, and fractions will follow the distributivity law also. That is what they meant there. Okay, rational numbers are closed under addition and subtraction, closed under addition, subtraction, and even multiplication also. I already told you in the previous session we have discussed what do you mean by closed under addition and subtraction. Okay, so what do you mean by closed under addition is when you add two rational numbers, you will get another rational number only. That is what is called as closed under addition. When you subtract a rational number from another rational number, you get another rational number only. That is subtraction closed. Okay, similarly multiplication also, when you multiply two rational numbers, you are going to get another rational number only, and that is what is the law of closure for the multiplication. You understood? Okay, now and finally they are saying it is closed under division only. Division also, when you divide one rational number with another rational number, it also gives you one more rational number only, but one specific condition, provided that one does not divide by 0. You should not divide by 0 because 0 is also a rational number. Okay, thinking that 0 is a rational number, you cannot divide take one rational number and divide it by 0. That condition does not apply. Otherwise, other than that, even the division is also closed. Okay, so closure law for division also applies for rational numbers. Okay, you got my point? Okay, so all these important laws you should read it and remember it so that you can resolve the next coming exercise set easily. Understood, right? Okay, let us apply all this knowledge into an exercise set and resolve the problems given in exercise set 3.3. Okay, the problems are simple only. Only thing is you need to follow the laws that we have studied previously. Okay, now prove that the following rational numbers are equal. Okay, now you know that this is equal 2 by 3 is equal to 4 by 6 only, because 4 by 6, if you divide it by 2, okay, so 2 2s are and 2 3s are, it is 2 by 3 only. It is already equal only, but you have to prove it. Now how do you prove it? Is by the equality law. By equality law, what equality law says is a by b is equal to c by d. A by b is equal to c by d if, okay, if a multiplied by d is equal to b multiplied by c. Okay, that is what the equality law says. So let us apply that rule here also. So therefore 2 by 3, okay, is equal to if you want to say 2 by 3 is equal to 4 by 6, then 2 multiplied by 6, that is a into d, okay, is equal to 3 multiplied by 4, right? So what is 2 6 is 12, and what is 3 4 is 12. So that is how you proved that AD is equal to BC, and that is the reason 2 by 3 and 4 by 6 are equal. Understood, right? So you can finally write, therefore 2 by 3 and 4 by 6 are equal. Okay, don't say that. Okay, so if you just divide it here, 2 ones are 2 2s are and 2 3s are, so it is equal. Don't do that. Okay, we know that those are equal only, equal fractions only, but we have to prove it according to the equality law. Okay, so all the examples in this set exercise set should be resolved with the laws that you have studied here. So that's why you need to note this and remember the laws. Okay, again and again I'm reminding you. Here also 5 by 4, if you want to prove it, is equal to 10 by 8. That is also, if you divide by 2 5s and 2 4s, it will become 5 by 4 only. But by equality law, okay, let us, I will not write it, you have to write it again and again. By equality law, A by B is equal to C by D if AD is equal to BC. I am just going to write directly that 5 by 4 is equal to 10 by 8. Okay, only if directly I will write, only if 5 into 8, that is A into D, is equal to 4 into 10, that is B into C. Okay, 5 8s are, that is 40, and 4 10s are, it is also 40. Simple only. Okay, so finally you can write, therefore 5 by 4 and 10 by 8 are both equal. Understood, right? Okay, let us quickly move to the next set of problems. Here also we'll have to prove that these two numbers are equal only, but here there is a simple difference that with negative values both the fractions are given. Here one fraction is exact the actual fraction, and another is a whole number, or you can even consider it as an integer also. Okay, now as you know that when a negative number is given, a number can be multiplied to the numerator denominator, or it can be even applied to the whole fraction. So now it is getting applied to whole fraction. Assume that, so I can say that 3 by 5 is equal to minus 6 by 10. I'll let me just apply that to the numerator for time being. Okay, that is also okay. And I will write only when minus 3 into 10, that is A into D, is equal to 5 into minus 6. And you know that minus into minus into plus is minus only, and it is minus 30. And here also plus into minus minus only, and 5 6 it is also 30. Okay, it's very very simple examples. Here also, though it is given as a whole number or a positive integer, you can write there will be a default denominator for any whole number, that is, or any integer, that there will be a default 1 as a denominator. So I will consider this as 9 by 3 and 3 by 1 only. So 9 by 3 is equal to 3 by 1 only when, you can say, only when 9 into 1, that is 9 into 1, that is A into D, and 3 into 3, that is B into C. Okay, it is 9 equal to 9. So therefore these two fractions are also equal. Understood, right? We proved it by the law of equality that was defined in this chapter. Okay, let us, okay, now the law of addition you need to apply here and resolve these problems. What was the law of addition? That you should remember this, right? Okay, so if the two fractions are given, the denominator should be first made equal. If not, denominator must be made equal. And when the denominator is made equal, then you can keep a common denominator and add both the numerators, and that will give you a final result. Okay, so let me write by addition law, or I can say by law of addition. Law of addition, you should be saying, okay, A by B plus C by B only. C by B, I am considering the numbers as having both denominators are equal only, and that is keeping denominator as the same, I can add the numerator. So it is possible only when the denominators are made equal. Okay, now let me consider this and make the denominator equal first. So let me consider the exact value first. And to make the denominator equal, I should be multiplying 5 by 2. So if I am multiplying by 5 by 2 here, I should be multiplying that to numerator also, so that to keep that value as it is. Understood, right? So what I'll do is divide and multiply by 2 to both numerator and denominator here. Okay, it is 5 by 2, and this is 3 by 10. Correct? So see, I'll just cancel 2 and 2, and it will remain as 2 by 5 only. That is the reason I did it. Okay, but when you multiply this, what you will get is 2 into 2 4, and this is 10, and this is 3 by 10. correct. I did not do any changes to the second number. Okay, sorry, it is not equal, it is plus. You're doing addition. Okay, now we came to this condition that the denominators are equal. So when the denominators are made equal, I can keep the common denominator and add both the numerators, that is 4 and 3. So what is the final value? That is 7 by 10. Okay, so 7 by 10, since we cannot divide anything more, I can keep that as a 7 by 10 as final answer only. But if there is something that you can divide and reduce that number to a smaller fraction, you can do that also. Understood, right? Okay, so again, the law of addition, I'm not going to write it for all the problems here. Yeah, I will start with this point only. You have to write that yourself, right? Understood, right? Okay, now here also both the denominators are not equal. I should be converting both the denominators into the same denominator, but it is not unlike the first problem. I cannot just multiply the second number denominator with some number and make it to 12, because 8 will not have any multiple as 12 in the 8th table, right? 8 to is 16. Okay, so I cannot multiply any number to 8 to get 12. So I should be converting both the numbers so that they will have the common denominator. You're getting it, right? So it is in general what we are trying to do here is, it is we are trying to get a LCM, least common factor, we are actually trying to get. Okay, but indirectly we are doing the LCM only. Understood, right? Okay, so what I will do here is, listen to me carefully. What I will do is, I'll just convert this to 24. See, 12 2s are 24 and 8 3s are 24. It is 24 is a least common factor of 12 and 8. That's why LCM of 12 and 8 is 24. Okay. So what I will do is 7 divided by 12. So when I multiply 12 by 2, it will become 24. I have to multiply that to the numerator also. Okay, see, I'm writing 7 by 12 as 2 multiplied by 2 and 2, making it 24, plus 5 and 8 to make it 24. I'm multiplying it by 3, so I'll multiply that 3 to the numerator also. Hope you are getting it simply. Okay, so we did not made any changes, but we have converted the denominator to the same value. 7 2s are, it is 14, 12 2s are 24. Okay, plus 5 3s are 15, and then 8 3s are 24. Now 24 is the same number in the denominator of both the fractions. Now I can keep 24 as the common value here, and 14 plus 15 is the value. So finally I'll have 29 by 24. Since 29 is a prime number, I cannot divide that number also anymore. So the final answer of 7 by 12 and 5 by 8 is 29 by 24 only. Okay, hope you are getting it. Okay, now simply do it for the third number also. Here I can just change the first fraction and make it 14, because 7 2s are, it is 14. Okay, so minus 4 and multiplied by 2, and denominator I'll multiply it by 2 to make it 14, and keep 3 by 14 unchanged. Okay, so it is minus 8 divided by 14 plus 3 by 14. Okay, and now 14 as the common denominator, it is minus 8 plus 3, and that is equal to 3 minus 8. Okay, that is minus 5 by 14. This is the final answer to minus 4 by 7 plus 3 by 14. Okay, by the law of addition defined. Understood, right? So now the next set of problems will be exactly similar to this, but with the negative sign. It is the difference that you are going to find. Here also you are actually converting the denominator to the equal value and subtracting the numerator values. That's all we are going to do. So for this also I'll write by the law of difference. Okay, for the first problem I'll write, you will write it to the other two problems. Law of difference or law of subtraction, you can say. Law of difference or law of subtraction. We will consider a by b minus C by B, okay, considering B as the common denominator, B, and it is A minus C in the numerator. So applying this law here, the values are 5 by 6 minus 1 by 4. Again you can see that here that 6 and 4 are two different numbers. To convert them to the equal denominator, I have to multiply 6 by 2 so that it will become 12, multiply 4 by 3 so that it will also become 12. So 12 is actually the least common factor of 6 and 4. That's why. Okay. So how do I write it? It is 5 by 2 plus divided by 6 by 2. Okay. It is minus. Okay. And it is 1 by 3 and 4 multiplied by 3. Okay. So 5 into 2, that is 10 by 12. Okay. Minus 3 by 12. Now we have the common denominator as 12, so that it is 12 and 10 minus 3. 10 minus 3, and that is equal to 7 by 12. So the difference between 5 by 6 minus 1 by 4 is 7 by 12. Hope you are getting it. These are all very simple problems. Let us go faster here also. So here also 8 and 4 we will have a common factor. Okay, and that is what is the common factor? 8 2s are 16 and 4 4s are 16. Correct, right? Okay, and that 16 is a common factor between 8 and 4. Okay, so let me write 11 into 2, because I'm going to multiply 8 also by 2, and minus it is 4 4s are, right? So 3 4s are and 4 4s are to make it 16, right? 11 2s are, it is 22 divided by 16 minus 3 4s are 12, and that is also divided by 16. We have a common factor, common denominator 16, and 22 minus 12. 22 minus 12. So what is 22 minus 12? Is 10 by 16. So 10 by 16, can I divide it a little more so that I can reduce the fraction to a smaller fraction, that 2 5s are and 2 8s are. Okay, 2 5s are 10 and 2 8s are 16, and that is equal to 5 by 8. So that is the reason I told, whenever you get a fraction that you can reduce little more, you can divide that by a common value and then reduce it to a smaller fraction. Now finally, minus 7 by 9 and minus of minus 2 by 3. Okay, so here you need to apply the knowledge of the previous session, that minus of minus will become plus. So that is debt of a debt will become the fortune. That is the reason you need to first write that as minus 7 by 9. Okay, and minus of minus, that is actually plus, and 2 by 3. So how can I write that is 2 by 3 minus 7 by 9? That way also you can write it. Okay, so or else you can continue in this way only, no problem. It is going to be a minus operation in the numerator only. So to convert the denominator as the equal denominator, I need to multiply this by 3 and multiply the numerator of that second number by 3. Okay, 7 by 3 plus 2 multiplied by 3 divided by 3 by 3. 3 into 3. Okay, so it is minus 7 by 9 plus 2 into 3, that is 6 by 9. Okay, so take it as a common 9, and it is minus 7 plus 6, that is 6 minus 7, that is minus 1. So it is minus 1 by 9. So the value of this is minus 1 by 9. Understood, right? This is the law of difference. Now similarly, we have the law of product and law of multiplication, distributive, commutative. All such examples are there in this set. Okay, let us see the multiplication, the product. Okay, now it's very simple. By the law of product, the numerators are multiplied and denominators are multiplied. You know that, right? By law of product, let me write it for one problem. You can write it for other problems. A by B, when it is multiplied to C by D, another fraction, then it is going to give us A into C divided by B into D, BD. Okay, so therefore 2 by 3 multiplied by 3 by 10. You can even cancel out and give the value as 2 by 10, and 2 by 10 even cancel out to 2 ones and 2 fives. That also is possible, but we are simply applying the law of product. That's the reason we are solving in this way. You're getting it right? Okay, so I will just first multiply 2 into 3. Okay, so it will be 2 into 3 divided by 3 into 10. Okay, and that will be equal to, finally you are going to get the similar answer only by 30, and 6 ones are and 6 fives are. It will be equal to 1 by 5. This is the answer. Or else you can, here only you can see that 3 will get cancelled, 2 ones are and 2 fives are. It is equal to 1 by 5. We know that this answer is 1 by 5 only, but you have to resolve in this way only because you are applying the law of product here. You're getting it right? Okay, now let us do this in a similar fashion, that 6 into 5, sorry, 7 into 5 divided by 11 into 8. I'm directly writing that. Okay, so it is 35 divided by 11 8s is 88. Okay, so it is 35 by 88 only because it cannot be cancelled with any common number. Here only you can get that. Okay, there is 7 and 8 will not get cancelled, 5 11 will not get cancelled, so there is no question of cancelling any value to it. So it is 35 by 88 only. So here it is minus 4 into 5 divided by 7 into 14. 7 into 14. Okay, so it is minus 20 divided by, it is 98, and now it can be divided by 2. Okay, so it is 2 ones are 0, I can keep it as, and 2 fours are, it is 4, and 2 nines are 18. Okay, so it is 10 by 49. So it is minus 10 by 49. You cannot divide anymore to make it a simple fraction. Okay, so that is minus 10 by 49 is the answer for that. You're getting it right? Okay, now similarly we will go for the application of division law also, but division law in turn is converted into a product law only, because we are actually taking the reciprocal of the second number and performing the multiplication operation only. Okay, so by law of quotient, or by law of division, you can say by the law of division, we are saying A by B divided by C by D is equal to, is actually equal to A by B multiplied by D by C, sorry, it is D by C, and multiplying A into D and B into C. It is AD by BC. This is the division law. So applying that here is 2 by 3. I will directly convert this to 10 by 3 because I am actually multiplying. I have converted this division operation to multiplication operation, and that will give me 2 into 10 divided by 3 into 3. That is 2 into 10, it is 20, and this is 9. Okay, 20 by 9 is the answer. Let us see the second problem. Here also you will apply the division law only and convert this 5 by 8 to 8 by 5 and say it is multiplication now. Okay, so 7 8s are, that is 56. Okay, okay, I'll have to write that additional step also. Okay, and it is 56, 7 8s are, and 11 5s are 55. So 56 by 55 is the answer for this. So this is minus 4 by 7. I'm doing it because you can simply convert that and perform the product operation or multiplication operation. 14 by 5, I have taken the reverse of that and converted the division into multiplication. Okay, 7 ones are 7 twos are, here only you can multiply it, or otherwise you have to perform the operation according to the product law, that is minus 4 the and minus 14 and 7 5s are, it is 35. In some of the examples anyway, finally you are going to reduce it by dividing some common factors. Here only you can try that also, that is your convenience. Okay, so 7 ones are and 7 twos are, I can do that, and minus 4 into 2, that is minus 8 divided by 5, it is 1 into 5. Okay, so minus 8 by 5 is the final answer for this. Okay, it is not that you have to divide at the final stage itself. Here only you can divide or cancel 3 and 3, 2 ones are 2 5s are, you can do it, but you have to perform the operation of the product law here. Okay, here also 4 and 14, if you want you can cancel and reduce that to some number. Okay, you need not go to the final stage and then only divide it. Okay, I did it because I just wanted to go through all the steps of the product law. That's why you're getting it right. So wherever you feel that there is some cancellation can happen, you can do that and reduce your work for the division process or multiplication process. Understood, right? Okay. So now we have completed all the basic arithmetic operations: addition, subtraction, multiplication, and division. Then we will see an example of the distributive law. Okay, you see that they are saying show that this left side equal to this value. If you clearly observe that 8 by 3 multiplied by 1 by 2, 3 by 4, there are three options here. 8 by 3, listen to me carefully, there are three operands or values: 8 by 3, 1 fraction, 1 by 2, 3 by 4. Here also you see 8 by 3, 8 by 3, 1 by 2, 3 by 4. You're getting it? So if you consider, see, if P is equal to 8 by 3, okay, and Q is equal to 1 by 2, okay, and or I'll say let P equal to 8 by 3 and Q is equal to 1 by 2 and R is equal to 3 by 4. Here in this example, if you write that, it is something like that. The distributive law, by distributive law, we know that, see, by distributive law, we know that P multiplied by Q plus R, right? It is in this format only. You are multiplying P at the end of this, but you can multiply that also to the beginning also, because multiplication is commutative. So it is looking that way only, right? P multiplied by, it is Q 1 by 2 and plus R, that is 3 by 4. And here also if you see P into Q and P into R, correct? So it is P into Q plus P into R. Therefore you can say that 8 by 3, that is 1 by 2, okay, plus 3 by 4 is actually equal to 8 by 3 into 1 by 2, 8 by 3 into 1 by 2, okay, and multiply the same number to the second number inside the bracket also, that is 8 by 3 into 3 by 4. It is exactly equal to this. Only difference is 8 by 3 is multiplied after the bracket and the left hand side, and 8 by 3 here is multiplied. It is QP and RP. Okay, but I can say this also, because multiplication is commutative. So this is an additional information. You need not write it, but since you know that law, you can give that reason. So this is in very simple steps. I can say that this is according to the distributive law, this is equal. That's all. Understood, right? Okay. Now let us quickly move to the next problem. Here also they are asking us to simplify this using the distributive property itself. Okay, using the distributive property itself, they are asking us to simplify this values. So what is the distributive law? By distributive law, you have to multiply the 7 by 9 to 6 by 7 also, and minus 7 by 9 multiplied by 3 by 4 also. Understood? Okay. So simply by distributive law, if you want, you can write that by distributive law or distributive property, as they are saying, P multiplied by Q plus R is equal to P, it is getting multiplied to Q plus P multiplied by R also. Or since it is actually minus they have taken here, I can apply this as minus also, because the distributive law applies with minus also. So instead of plus, I will take it as minus. Okay. So let us apply this and take this 7 by 9 divided by, what is the next fraction? 6 by 7 minus 3 by 4. Okay, is equal to, multiply 7 by 9 to both the numbers inside the bracket. 7 by 9 multiplied by 6 by 7. Okay, minus 7 by 9 multiplied with 7 by 9 multiplied with 3 by 4. Fine. Okay, now cancel 7 and 7 here, and 3 twos are and 3 threes are. So what remained in the first value is 2 by 3. Okay, minus, I'm cancelling 3 ones are and 3 threes are here. So what remained in the second is 7 ones are 7 divided by 3 fours are 12. 7 divided by 12. Now it is reduced to a fraction difference of the two fractions. So how do I have to reduce? By the law of subtraction or by the law of difference. So that is, I have to make the denominator both equal, so that I have to multiply it by 4 and divide it by 4. So it is 7 by 12 again. So keeping the 12 here, I am making the denominator 3 as 12. Okay, so 2 fours are, it is 8 and 12 divided by 12 minus 7 by 12. So you know, when both the denominators are equal, I have to keep the denominator as same, and 8 minus 7, 8 minus 7, so it is finally 1 by 12. So that is the simplified version of this. Let us go to the next problem quickly. Okay. Now the next problem is to find the rational number x such that there is a equality of the sum of fractions given here. 5 by 6 into the bracket x plus 3 by 5 is equal to 5 by 6 into x plus half, 1 by 2. Okay, now if you look at this problem carefully, here this is also a distributivity law only. Okay, you are seeing that, see, 5 by 6 when it is multiplied to x, you are going to get 5 by 6 into x, and 5 by 6 when it is multiplied to 3 by 5, see, 3 ones and 3 twos will get cancelled, and 5 will get cancelled, and it remains as 1 by 2 only. So it is already equal. It is already equal only. Okay, of course, when you are asked to find out x, then you have to make x to the same side, so that you can get the value of the constant value which is equivalent to x to the other side. Okay, let us do that here, and let us see what value we can get. It is the distributive law only. Okay, now let us simplify the left hand side. 5 by 6 and x plus 3 by 5, as I already told, it is already equal to the right side part, that is 5 by 6x plus half. Okay, now let me multiply this to the simplified version, that 5 by 6 into x. When you multiply this, it is 5 by 6 into 3 by 5. Okay, and no change in this, 5 by 6x plus half, 1 by 2. Now as I already told, 5 here will get cancelled, and 3 ones are 3 twos are will get cancelled, and what remains here is 5 by 6 x plus half is equal to 5 by 6 into x and plus half. So if you see the two equal quantities, 5 by 6x and 5 by 6x can also be cancelled, and 1 by 2 1 by 2 also be cancelled, or otherwise if you want to keep the constants, you can take that as two equivalent values. So it is half is equal to half. Half is equal to half is one numerical value is equal to the exact numerical value of the similar kind. So it is a universal truth. Okay, so this statement, since you can say that inverse, you didn't get. So what I am trying to say here is you did not get the value of x, but you got the whole expression's value as equivalent, and that is equivalent to true. Okay, half is equal to half is true. So if you would have got as half is equal to minus half, then that is false. Okay, you're getting it right. So the whole expression's value is true. You did not get the value of x, but the expression's value is true. So what do you mean by this? Listen to me carefully. What do you mean by this? When you get such a result, it means that for any given value of x, this equation is going to be true. You getting my point? Okay, you put any value, any rational value to x, you are going to get this as equal only. Okay, you see that you are here only. You can see if I put x is equal to 0, it will give me half is equal to half. If I get x is equal to 1, 5 by 6 will get cancelled, half is equal to half. So any value of x you put here, any rational value, this expression is going to be true only. So there is no question of finding any specific value for x. This is a special case in such problems, that you will not get any single value or double values that can satisfy this equation. You getting my point? So therefore you can say that since the expression's value, you can say expression value is true, you can say this expression value is true, we can say that for any or for all rational values, for all rational x, this expression is true. This expression is true. So some statement I've written, you can write it in your own words, as I always say it. Okay, so the final thing is, when you get such situations where you don't get the value of the x specifically, you should say that it is for all value of x. If you don't get this as true, as I already told, if you don't get, suppose that you get my 1 by 2 is equal to minus 1 by 2 or any other value which is not mathematically true, if you get that value as false, then you should say that for no value of x, this equation can be true. Here, since the whole expression is true, you are saying that for all values of x, this expression is true. Okay, I have explained it more than sufficient now. Okay, hope you understood this. Okay, now we have completed the exercise set 3.3. Okay, but we are now into the new concept, that is representing the rational numbers onto the number line. As we have discussed in this session only, how do we represent the rational numbers onto the number line that is between the two whole numbers. Okay, now it's already a lot of time we have spent on this. Let us discuss this concept of representation of rational numbers on the number line in the next session. Okay, thank you.